Good evening. Thank you. So I'm a data scientist at the University of Michigan. I work in the Office of University Development. And what I work on is fundraising analytics. So basically finding prospects for the university for the various initiatives that we have. So what I'm going to talk about today is three things. One, I'm going to kind of give you a background on fundraising analytics, where we are, where we came from and where we are now. Then I'm going to go over a tool that we're using at the University of Michigan called Word2Vec. And we're using that tool, it's a machine learning tool that we're using to make sense of a lot of the text that we come across. And the third thing that I'll do is actually give you three examples of how we've implemented the tool at the University of Michigan. So this meme basically represents the old fundraising model. Trust me, I'm a doctor. So what I mean by that is that the way that fundraising was done before was it kind of went in just one pool, right, at the university. People would give money to the university and trust that the university knows what best to do with the money. But now the model has actually changed, where we have this Steve Jobs quote: the ones who are crazy enough to think that they can change the world are the ones who do. So now we're meeting donors that are way more involved, right? They don't just want to give money to the university and walk away. They actually want to solve specific problems. They want to be involved in the process. They want metrics and things like that. So it's a very, very different kind of model of fundraising that we're experiencing now. And this has actually changed the way that we fundraise for campaigns. Again, before we just got everything going in a pool, but now we're splitting it up into different initiatives, and many of these initiatives are cross-disciplinary initiatives. And I'm going to give an example of that and just how that works. So before, if somebody just gave to the College of Law, if that was the old model and that's how people were giving, then that was it. Like, the process of dealing with the donors' funds and all of that just went straight to that university, to that school in the university. But with something like malaria, if a donor comes and they're interested in working on malaria, well, there are multiple aspects of malaria. There's the epidemiological aspect, there's the health service delivery aspect. How are you going to, what are you going to do to prevent malaria? Or when people get it, how are you going to provide the services? There's the economic aspect. So even if you know how you're going to provide the services and you know how it spreads, do you have enough money in the country that you're in to actually pay for those services? And then there's the social and psychological aspect. Now, if somebody's giving to malaria, what school does this go to? Like, there's no one school in the university that this will go to. This cuts across multiple disciplines. And so that's one of the challenges that we're facing. Now, talking about this old model of fundraising, also we had an old model of analysis. So before, we have a student that comes to the University of Michigan. We've got a lot of their information in terms of when did they start, how long did they attend University of Michigan, where are they from, have they donated before. All of these were elements that we would use in our model. For instance, prior donations are one of the biggest indicators of donating in the future. We would look at things like, did their parents go to the university before? Because this increases their affinity, right? So if it's not just them going to the university, but maybe their mom, maybe their grandma, their dad that have gone to this university, they're going to have a much deeper connection to the University of Michigan. But one of the things when you start actually looking in the database is that you do have a lot of people that conform to this, but you'll start seeing weird things, right? Some of our biggest donors at the University of Michigan didn't even attend the University of Michigan. So how do we capture that? That they're not even in our database necessarily, other than that they gave. So how do we know that there's somebody out there that wants to give to University of Michigan that didn't go there? So that's something that's not in our database. So what we kind of found, one thing I forgot to mention is, another thing you look at when you go in there is you'll see weird things again. Like, you'll see somebody that graduated in mathematics, right? But almost all of their money went to the botanical gardens. Like, why? You know, there was another instance, somebody had a, what was it? It was a urban planning, but all of their money went to public radio. So again, these are things that it would be, I mean, our database doesn't give us the information to know that, but we basically had two takeaways from this. One, that everything that we need to find these prospects is not in our database. And two, that we had to find some other source to implement to buttress kind of what's in our database. How do we get data elsewhere about people that can allow us to create a better model? So again, well, there's a world out there waiting to be explored, and that world is the world of publicly available data, right? So we're not throwing our database away, we're just adding to it, right? So this is a guy that actually goes to the University of Michigan. He graduated from the University of Michigan and works at the University of Michigan. So we've got all the standard stuff in the database about him, but then we also can go to his Twitter profile. He's written 2 books, so we can go to Amazon and get that information. You can find him on Google, find him on LinkedIn. He has taught data science courses, so that's another way. So we can bring all of this data together with the information in our database to get a much better idea of what this person is interested in. Because that's basically what we're trying to do. We're trying to learn how do we better, we're trying to do affinity-based fundraising, right? Where we fundraise with people based on what their actual interests are. Because that's going to be a more fulfilling experience for them, and it's going to be more fulfilling for the university. It's going to work out better for everybody if we can do that. Word2Vec to the rescue. So now I'm going to get into the tool that we're actually using at University of Michigan. So I'm going to explain how the Word2Vec algorithm works. The first thing you need to do to implement the Word2Vec algorithm is get a huge collection of text. Okay, so some people have used all of the pages on Wikipedia. So you could use New York Times publications from 1950 to 2010. And so what will happen is that Word2Vec will get all of the words in this collection of text first. The next thing that it will do is it will just randomly throw them on a graph, right? So I'm distilling this algorithm. It actually ends up working in 300 dimensions, but I'm kind of distilling it down to just a 2D version. So that's the first thing that it does. Now, at that point that it's collected all the words and it's thrown them randomly through the graph, it will then go sentence by sentence and begin to see how words are used similarly, and it will begin to cluster those words. So these are the same words that I just had up there, right? But certain words are used similarly. Sylvania, Toledo, Perrysburg. I drove to Toledo. I drove to Sylvania. I drove to Perrysburg. Those words are used in a very similar manner. These are cities, we use them in a similar context. Here at the bottom we have cat, dog, bird. Again, animals, similar words. It's gonna move them closer together because the concepts are similar and they're used similar in language. So that's the kind of the foundation of what Word2Vec does. Everything, now it's time for you to provide it your text, right? So here, I just came up with a random, this is like a random tweet, right? So my cat needs new kitty litter. So as you saw in the last slide, every word on the graph has a point, right? Similar words are clustered, but every word has a point. So what the Word2Vec algorithm does is it takes every word in this sentence and it creates a point. My has a point, cat has a point, need has a point, new, kitty, and litter. They all have points in this graph. And then it sums all of the points up into one point. Now, here you see that we have a lot of cat-centric words. We got cat, kitty, and litter. So if we go forward, that point for that tweet is gonna be right here, right? It's gonna be, right in this, right near, definitely near animals and even closer to cat in particular. So the whole idea is that you've now gone from text to actually, you've transformed text to something numerical and something that you can see distances from. So you can see concepts now that are close to each other or far from each other. So the concept of that tweet, like I said, it was cat-centric, so it's close to cat. If there was something that was close to the concepts of cities, it would be closer to this cluster at the top. So Word2Vec is allowing us to make concepts now mathematical. So I'll give you an example of, this is the first example of how we're actually using this at the university. We built a search tool, very much like a Google search tool, right? So we got LinkedIn data, that's what's on the back end, and on the front, you can just put in any phrase that you want. Now these phrases are for initiative prospecting. So let's say you want to know the top prospects for sustainability. So you can go to this application, type in sustainability, and it will rank the top prospects. And what it's ranking again is, it takes those people's LinkedIn text and it says, which of these LinkedIn texts are closest to sustainability? You could put in another one of our, you put in data science. Data science is another one of our initiatives that we're doing. So you can put in data science and you would see the people that are ranked, you would see the top prospects for data science. Now you can do the top 5, top 50, top 500, top 5,000. We get this algorithm to work in about 4 seconds. And we're trying to speed that up. We're going to do some parallel processing that's going to basically make it run instantaneously. So we've been putting in hamburgers here. So everybody loves hamburgers. And when we put in hamburgers, we got people whose LinkedIn profiles, they were connected to Five Guys. They worked in the restaurant industry, so on and so forth. So this was a manual process. To find the top prospects before was something that people had to do manually. We could pull information out of the database based on some kind of search criteria, but that was database information. Remember, now we're using just unstructured text information to do this. So then another example, another thing that we're working on is fund tagging, right? So sometimes you have different funds at the university. You might have the John and Jane Q Foundation Fund. Now that doesn't tell you anything about what that fund has to do with, right? So some funds have descriptions. All funds have descriptions actually, but some we had access to immediately and others we've begun to collect, right? Because by collecting this and getting the fund description, now we can begin to classify these funds. So if the president of the university says, hey, you know, we're going to be fundraising for diversity, equity, and inclusion. I want to know all of the diversity, equity, and inclusion funds. Again, this was a manual process. Could take a month or maybe more. Again, this is a process now. We can do this in about another 4 or 5 seconds again. So there are two things kind of going on. We're definitely getting the benefit of automation and speed, but then we're also getting the information of, again, at a university, you got so much text flying around. We've had text for a long time, but the question is, how do we make sense of it? So now we're even getting to the point where we're starting to be able to get access to more text at the university so that we can better understand prospective donors. Through a lot of the little kind of exploratory projects that we've done, we do them and we show that it's a value, and now more and more people on campus are getting interested in, hey, how can we tap into this? How can we give you data that can help you give us further insight? So this is the most exploratory one now, but probably the one that's kind of most exciting to me. Again, we're at a university, everybody has a transcript. And so right now we've only been doing this with people who are volunteering their transcripts. We're just trying to see if it works, see what results come from it. But basically, we got online and we scraped all of the course descriptions from the University of Michigan. So we can now, when we get a transcript, we can now link that just, English 208. We can now link that to an actual description of the course. So in essence, we can get somebody's transcript and run it through Word2Vec. So we can see when this goes through Word2Vec, you have all of the courses that you've taken on your transcript, and Word2Vec gives you that point. We can see what concept that you are closest to from your transcript. And so remember I gave the example earlier of people donating in places that are seemingly different from where they had the majority of their experiences in the university. So you're a math major, but you end up donating to the arts. Well, this might help us reveal something like that, right? because you have a certain number of electives. So maybe we see that that person who ended up doing that, well, they took a lot of art electives, right? So we shouldn't have been thinking from the first place that they would only be interested in math, because, I mean, upon looking at their transcript and the course description, we see that they've had an interest in art for a while. So this is this is very helpful in terms of future donations and, like I said, career trajectories. That's something that we could possibly begin to get insight on through using this tool. So there are a few caveats about this tool. The first one is that, to some degree, Word2Vec depends on neural networks, which basically kind of simulate the neurons in the brain. And the challenging things about neural networks is that they're very challenging to explain. We know that they find patterns very effectively, but if you use something like linear regression, it's very easy to show, oh, you know, this is having an impact on this. But with neural networks, we just know it works. It's giving us what we're looking for, but how do you actually explain that? And again, we said Google, this Word2Vec uses 300 dimensions. Now this is the base setting. You can use 300. You can move up to 600 or 900 or as many as you want. But again, that, you know, again, it's kind of a bit of a black box process. You know, what does that mean? What are the 300 dimensions? What's being used, so on and so forth. So that's kind of a caveat, because usually when we're using things, we do want to, we want it to be as open and clear as possible. But tool still has value, but that is one drawback. Another thing is that words have different meanings in different contexts. So again, I told you about the initiative, diversity, equity, and inclusion. So we put in diversity, and we were just getting all kind of wild stuff, like genetic diversity, plant diversity, animal diversity, stock diversity, which wasn't the diversity that we were looking for. So this is kind of a challenge with the tool. The way that we got around this was, again, remember, it doesn't just have to be a word that we put in. We can put in a phrase, we can put in a sentence. So simply, instead of putting diversity, if we were looking for genetic diversity, we would just, in that search interface, type in genetic diversity, or we would put in stock diversity. So that was a way that we ended up kind of being able to get around that. So we have just really started with this. I mean, we've probably been doing it for about 6 months, but we haven't it's just really the tip of the iceberg, you know, where we are, because we just did the most stripped down, simple implementation of this that we could, just to see if it worked. And it did. We've already replaced some manual processes. We're getting more requests and interest in what we can do with Word2Vec, how it can help different units on campus. So there's a lot more to be done, and there's a lot more that can be done with the tool. There's a lot of tweaking that we haven't done. For instance, the process I told you of getting a huge chunk of text, when I talked about all of Wikipedia or New York Times for 60 years, we used a model that Google provided that had already been done. But we could use our own text. We could train Word2Vec on our own text. So that's one thing that we've talked about, getting all of the HTML pages on the University of Michigan site and using that as a way to train the model, because that would be more specific to Michigan. So many different opportunities, but it's already begun to show that it's a very powerful tool. So that is actually the end of my presentation on University of Michigan and Word2Vec. But just last week, Open Toledo was started, which is a branch of Code for America in Toledo. And Open Toledo is going to be focusing on civic tech and government tech. And so those two technologies are about increasing civic engagement through technology and helping government to run more efficiently. I think one of the biggest things about this, I've got this quote, there's actually an article from the Stanford Social Innovation Review that talks about how open source software is a form of philanthropy. And I think one of the things I'm just kind of encouraging anybody who's interested is to look into Open Toledo and see how we can work together. The big thing about Civic Tech that's different from other kind of software is the fact that Civic Tech is about working with the community to make software, right? So it's not a process where you just have engineers or just web designers or just people that are good with databases, but you have people in the community, could be anywhere in the community, that have ideas about how to use technology to make the community better. So we have a meetup group, and if you're interested, you can check us out there.